take me home, take me on a ride. I got a good feeling about the colors lighting up your eyes. Take me home, take me to the sky. I got a good feeling. Tell me the only thing you are is mine now. Na, 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 na. I got a good feeling. Na, 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 na. I got a good feeling. Good feeling. You wanna know is how to hold on to it every moment. Dive into it like my love is an ocean. It's overflowing. I swear it's golden. So good that I'm rolling. Baby, you make me crazy. I'm seeing roses. Baby, just maybe you save me. Oh, take me home, take me on a ride. I got a good feeling about the colors lighting up your eyes. Take me home, take me to the sky. I got a good feeling. Tell me the only thing you are is mine. Take me home, take me on a ride. I got a good feeling about the colors lighting up your eyes. Take me home, take me to the sky. I got a good feeling. Tell me the only thing you are is mine now. Na, 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 na. I got a good feeling. Na, 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 na. I got a good feeling. Good feeling. Na, 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 na. I got a good feeling. Na, 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 na. I got a good feeling. Good feeling. You wanna do is move with me, move with me. I'm seeing blue, yeah. In a disco-colored room, hearts are blooming. It's so consuming. Love what you're doing, so good that I'm doomed, yeah. Baby, you make me crazy. I'm seeing roses. Baby, just maybe you say.
Oh no, the camera is is frozen again. 1 second.
Tell me the only thing you are is mine now.
No, didn't work. Wait. Okay. Okay, it's working. I don't know what's with this camera. It wasn't working on Friday. And then yesterday we did a Twitch stream for like 6 hours and it didn't froze once. I have no idea what's going on with it. Let me open my chat so I can reply to you guys. Oh, why isn't it opening? What? What's wrong today? Okay, cool. Cool. We can start. It was a wild day. So where did we stop last time? We were building this lure turner for making fishing lures. And we're almost done, by the way. We need a couple of stuff here just to refresh my memory. I should probably prepare before the stream, but yeah, what the hell. So we still have to add this part right here, which is gonna have a ball bearing. I'm thinking it could have 2 ball bearings because the previous version had 1 and it could wobble a bit, so adding a second one would be a great idea. So two ball bearings here, and we need something to attach the hook to. I'm thinking I'm gonna go the same route I went with the previous lure turner, which is making it as a screw, modeling it as a screw on both sides, from this side and from this side. And as I said, 2 ball bearings, so it can rotate. And What else? Then we can basically attach anything to it. Since it's a screw, we can create attachments like attaching a single lure, or you can, for example, attach a magnet bar or something, or let's say someone else created their own attachment. That would be cool. That would be very cool. And okay, so that's one of the things we're gonna do today. The other thing is I'm not worried about this one at the moment because it's free to move back and forth. We need somehow to attach this object. Where is it? The motor holder. We need to attach it to this one. So we'll see. We could put screws on the bottom. That's one option. Or we can just have a 3D printed pen that goes sideways here, for example, to hold it in place. Let's see. I might add support to this to make it more stable. Maybe like something like this goes from here to here to support it. What else do we need to do? What else? Just to give you a heads up, today I'm not thinking straight at all. Actually, here's a story. So I had an appointment this morning. I had two things actually. One thing at the office, and another thing is at the ministry. So I had to be in the office at like 9:30 in the morning, and then in the ministry I had to be there by 1:45. And so I went to the office. It's like about 10 p.m. something like that. I've finished my thing, and I know that the appointment at the ministry is like at 1:45, but somehow in my head things got mixed out, and I was like, okay, I need to be there in 2 hours, and it's like 4 or 5 hours ahead. I'm like, I need to be there in 2 hours. I don't know how I calculated this. So I texted my wife, hey, you need to be here in like an hour. So yeah, we spent about 4 hours just wandering around. I'm not thinking straight at all today. But anyways, what else do we need to do? Yes, it's an important one. So we decided that these moving platforms or the base plates, we can stack them up. So we can have 2, 3, 4, however we want. However long we want it to be, we can stack them up. So we need also some way to attach two of these together. Yeah, let's see what we can do. Hopefully we can finish all of this today. So what do we start with? I'm guessing we can start with this. Let me just refresh my memory on how we, let's see, motor holder parameters. Motor offset from top is 5, and then we have a motor diameter, and then we calculated some values here. This screw hole distance, motor offset from top. Okay, and how did we do this sketch? Yes, Z value here, what was it? It was the height minus motor offset from top minus motor diameter divided by 2. Hello, I just joined. What kind of motor are you planning to use? Okay, hello Oddlures, and the motor that we're planning to use is called was it asynchronous or synchronous? Yeah, this one. This thing, it doesn't have to be this exact model. There's like millions of them on Chinese websites or but yeah, it's an AC motor, sorry. I guess it could be what is it, 110 volts or something, the US voltage. But the shape I think will remain the same, and we're doing it parametrically, so I can show you. Everything here is parametric. We can change anything. Let's see, base plate. I forgot the parameters. I can change the height, for example, to like 250, and then everything will re-render. Okay, I have a sketch that I forgot to hide. Yeah. What was it? 150. I'm gonna leave it at 150 for now. But yeah, we can change anything, and the plan is to, as I was saying, so this part right here, the moving platform, this is not, it's not, how do you say it? It's not static, it moves actually on this platform. And the plan is to have as many of these moving platforms as necessary. So you could put one lure on this platform and then put another lure on another one behind it, and then like somehow we need to let them attract each other. So I'm thinking it's either gonna be like a screw here and then you squeeze it by hand and tighten it down, or we can have rubber bands going from this one to this one, or it doesn't have to be rubber band. It could be a spring, for example, connecting this part to this part, and then you can like stretch it, put the lure in the middle and let it go. And you can do the same with the rest, and then you can have like 10 lures rotating on the same motor. That's the plan. And it doesn't have to be one lure, because we're gonna create attachments. So we can make an attachment, for example, that can hold 2 or 3 lures on the same platform. Nice. I have just tested FreeCAD a bit. Beginner in CAD. I used to designing masters and blenders, so this will be some good learning for me. Yeah, so FreeCAD definitely has a steep learning curve, but once you get the hang of it, it becomes super easy. And they are they already did that. They already merged lots of fixes to the master branch on GitHub, so it should be released soon, version 1.0, which is the first stable version of FreeCAD, hopefully, and it's gonna be awesome. They're doing lots of work on user experience, especially for newcomers. But for now, basically, I have a rule: never select a face and draw a sketch on it. Never reference an edge. Never do any of that, because in the current version of FreeCAD, you can technically do it, but it might break everything if you modify something. That's the only way at the moment to achieve a parametric model, is to draw everything according to parameters and not referencing anything. Like, for example, this motor right here, motor hole, if we check the sketch, we can see that it has a height and a diameter, and these heights and diameters, we have them here. We're referencing them from separate spreadsheets. Now we're gonna do the same for the hole that we're gonna do here. So let's do that. Moving platform parameters. So at the moment, for the moving platform, we only have the rail length, which is, let's set this to 60, which is this thing here. So we need to add the hole. Let's see, moving platform parameters. But do we need to add it here, or should we create a new spreadsheet for it, because it's another part? It's a different part. I think we're gonna create a new spreadsheet. Let's create a new one. Let's call this the tool. What are we gonna call it? Tool what? Basically, it's gonna be a screw that will hold some attachments. not tool. Let's call it the rotating bit or something. Rotating screw. Okay, so part design. Rotating screw. We need a diameter here. We need the screw. Yeah, parametric design is amazing. Like, to be honest, I'm over engineering most of my stuff because of it, but but yeah, it's awesome, especially if you're making something and it has to go through multiple iterations to get it perfect the way you want it. If it's not parametric, then it's gonna be a pain. But if it's parametric, it's just like you change a number, reprint it, doesn't work, change a number, reprint it again. Okay, so let's add random values, a random value for the diameter. What else do we need? We need the bearings. Okay, so we don't need the diameter. We need the bearing inner diameter, and this, based on that, we will figure out the actual diameter of the thing. Or no, actually, no, we can have it diameter, bearing inner diameter, bearing outer diameter. So the hole that's gonna be cut here will be based on the bearing diameter. But the diameter of the part itself, it doesn't have to be this. It could be something else. Bearing inner diameter, bearing outer diameter, let's say 8 by 12. I don't know, I'm adding random values. Let's say this is 10. What else do we need? For now, I think this is enough. And we need to add the aliases, but we need to call them an input for now, similar to what we did in the previous stream. So these are all inputs. We need to validate the input before we can do anything with it. So now let's do that. Usually I use the K field. I don't know why, because I can just hide it like that, so I don't modify it by mistake. So let's see, what is the minimum value for diameter? Let's see, we need a minimum value of 5. No, maybe bigger. Yeah, I think 5 is fine. So we can test that. If we set it to 0, it should be 5. Cool. And this is gonna be the actual diameter. I love how Fusion uses spreadsheets instead of using like their own UI and stuff for adding parameters. It's so freaking powerful. You can add tons of formulas, like calculate absolute values and stuff. Nikita, hello. Hello, my brother. How are you, man? Okay, bearing diameter is gonna be also we need to add a minimum value for that. So let's set it to also 5, I guess. I don't know. This is the bearing input, the bearing diameter, and the bearing outer diameter, it has to be bigger than the inner diameter. So here the minimum value is gonna be the bearing inner diameter, or sorry, we need to first say bearing outer diameter input is the value, and the minimum value for it is inner diameter plus, let's say plus 4. So if, for example, I go to the outer diameter by mistake, set it to 4, it's gonna say nope, you can't do that. The minimum is gonna be 12 because the inner diameter is 8 and you need at least 4 mil between the two. And we're gonna call this the bearing outer diameter. Okay, still accepting the new path, if you know what I mean. Yeah, definitely know what you mean. I'm about to design something similar with UV lights that I can use when prototyping. Did a larger turner with extruded aluminum, 3D printed parts, and a stepper motor used for regular epoxy. Dude, that's overkill. You mean? I once had an idea. Why not use a stepper motor? Connected to like a Raspberry Pi or something with a stepper motor driver, and then you can start adding knobs to control, for example, like the speed, the direction. But yeah, that's overkill. Quick recap, what are you doing here? So quick recap, we are building something in CAD. So this is parametric. Nikita, I don't know if you know about 3D stuff, but basically uh, CAD is like the SVG of images, but in 3D. So here I can modify parameters, like let's show you, like let's set the width to 200, and then this will modify in real time, and I can like export it and print it, or you can use it in games and whatever, anything that requires a 3D file. Yeah, so it definitely has limitations. You can't do something photorealistic or like add lots and lots of details, but for things with sharp edges, maybe fillets and stuff, and simple curves, it's super powerful. So yeah, what we're trying to design is a lure turner. So people who make fishing lures, when they create a lure and it's done, they paint it and everything, they apply a layer of clear coat on it, which is called, it's usually an epoxy clear coat, could be something else, but to have a super smooth clear coat, you need to keep rotating the lure. It's like a barbecue thing. But that's SVG, I get it. Quite good analogy, like SVG, yeah. Yeah, definitely a good analogy. Yes, so what we want to do now is the moving platform. So we have multiple objects at the moment. We have this object, and this one. And I want to add a cut here. Let me see, do I have any... I don't have any planes here at the moment, so I need to create a plane. But first, let me see, where is the origin? Oh no, we don't need a plane. Cool. Cool. So the origin is here. This is one of the things I also love about FreeCAD, is if you're using the part design, each object has its own origin, its own X, Y, and Z. And if you want to move the object, then you can go to data, placement. For example, at the moment I have this, I have the X position taken from a spreadsheet, but let's, for example, move it on the Z axis, and you see the entire thing with its origin moves up. So now we have the origin here. I don't need any extra planes or stuff. I can just create a sketch. Oops, sorry. Yeah, so we need to activate the body to be ordered to be able to do something with it. XY plane. So now we're drawing on this face right here, and we can do that. Okay, so this is gonna be the hole that will fit the ball bearings. And I think I forgot to add one parameter. Wait. No, rotating. This happens with FreeCAD. I hope they fix it. But sometimes when I'm switching between these, it glitches. We need the bearing width, basically width. And let's say this is 6. And this is an input, and we need a minimum. So this is gonna be max between the bearing width input and let's say minimum 2. I use Arduino with a fixed speed signal and have managed adjusting the step speed with some switches. of the stepper driver I use. Would be nice with the knob to regulate the speed. Yeah, the knob is amazing. I mean, if you can do that and put it in like a really good package, like a production ready package, you can basically sell it. I guess lots of people would buy it and they would pay good money for it. Good business idea 2024. Don't steal it. Okay, diameter. So we want this. We want to get it first from the spreadsheet. I called it rotating screw, and we want the bearing outer diameter, but we want to add some tolerance. Now I have a tolerance value in general, but this is not a tight tolerance. For the bearing, I want it to be tight, so let's add the bearing tolerance here. It's something like this, very small value, so we had to like hammer it in to put it in place. And let's see, this is gonna be maximum of bearing tolerance input and the value of 0.05. Okay. By the way, how's the volume? Okay, should be good. Yes, so we need to add the tolerance now. This is the rotating screw dot bearing tolerance, but we need to multiply by 2 because it's a diameter. Yeah, a lot of lure builders here in Sweden is often searching for turners or asking for tips on how to build them, usually built in wood with a disco. Man, Sweden, I love Sweden. You're from Sweden, you're so lucky. It's like the best, I guess, pike fishing destination. My friend is in a fishing trip to Sweden. I don't know if he's back or not, but he sends me a lot of pike pictures. Okay, so the height of this is gonna be exactly the same height as the motor. So we did that. How did we do that? We got it from the general.height first. So now we're here at the top. And now I remove from it something called, what was the name of the spreadsheet? It was the motor holder params dot was it offset from top. So now we applied an offset. I think it was like 5 mils or something, but we can change it. And now we need to go down by the radius to get the center. So this offset it's more of a margin than an offset. I should probably rename it. And this is gonna be the motor holder params dot motor diameter. Is it this low? No. Oh, I forgot to divide it by 2. Wait. Huh. No. This one. Divided by 2. Okay. So now we should have, these two circles should have the same height. We can close it and we can now pocket it. So pocket is like a, it's like an extrude infusion through all. But pocket will only cut, it will not create new geometry. Pad will create new geometry. New geometry. Okay, cool. Now one thing we didn't take into consideration is we didn't take that into consideration. So we have a thickness here. And we have 2 bearings inside and each bearing has a width. So I'm guessing we need to modify this so that it takes the width of the bearing into consideration. basically. But we'll do that in a bit. Yeah, one of the best for pike fishing. That's what I usually fish for and make lures for. Yeah, and you guys have lots of lure builders also. And you guys make amazing lures. Okay. So let's do that real quick. I think it was this pad right here. This was this. Wait, no, sorry. This was the sketch. Yeah. So this is the pad. And how much are we padding? We have to click it open. Interesting. Just 10. Wait, what? If I go here and change the thickness to 20, what's gonna happen? Recompute failed. Interesting. Okay, looks like I forgot to do some stuff. Let's see. Pad here, it's gonna be general dot thickness. And what about the base plate? I think no, it doesn't have its own thickness. What did I do? Base plate pad, it's from a sketch, and this 10 is what? Oh, base plate has its own thickness. Okay, close. So this one should be fine now. Okay, cool. Go back to general, change the thickness to 10. Recompute failed. Why? Why did you fail? Huh. Interesting. So something is wrong here apparently, and let me check the position. Let me check how did I move this here. So start by a thickness, then a tolerance, then the length. Yeah, that seems right, but it's in the wrong. Let me recompute. Recompute failed. Interesting. Moving platform 25. Recompute failed. This shouldn't happen. It's not changing anything. When I click reverse, it renders correctly. No, it doesn't. Huh. Let's see, how are we gonna debug this? So the origin is wrong also. It should be right here, and there is no reason for it to be back here because yeah, there is no reason for it to be here. It is possible to do split view with the sheet view and the model. Sorry, I'm not strong in terms of, yeah, I get what you mean. So basically you're saying, can we, to be honest, I never searched this, but it would be amazing. FreeCAD split view. No, not split view. you two what is it called? Panels at once? Oh no, panels is something else. No. Anyways, I don't want to waste too much time on this, but I will research it. But it might be annoying also, because then you're gonna be left with a small window. Maybe if you have like an ultra wide screen, then yeah. Master of over optimization. Okay, but no, seriously, there is no reason for this to be here. A compute object failed. What? Okay, this is bad. Why is it here? It should not be here. No. It should not be here. Bad thickness. Okay, but what did I change? This was 10. I changed it back to 10. What? General dot thickness. It's gonna be something silly, I know, because today I'm not thinking straight since this morning. I can probably just redo it, but I don't want to do that. Why? Okay, so coming to here, this binder has the correct placement. It's tolerance plus length plus thickness. That's exactly what we have here. Thickness, tolerance, and length is the same. Wait, what? Minus thickness? Oh, wait, yeah. No. Yeah, no, it should be minus thickness because here we should start from this point and go this way by thickness. So this isn't the correct. Okay, thank you, Nikita, for joining. Have a nice day. Or what is left of the day, anyways. No, it shouldn't be like this. No, it's not. Still, it's not moving anyways, no matter what I put here. So tolerance plus general dot thickness. I have to know what's wrong. What did we change? We changed the width, right? We changed this to like 200. And then we reverted it back. Yeah, looks fine. Huh. That is the weirdest bug I have seen. And it's probably because, let's see. No. Oh, wait. Wait. What is this? I think I got it. Around the width. Dot height. But something is missing down here. What is this? No, not this pad, sorry. This pocket. You think that is the issue? Let's see. This is fine here. No, it's fine. So this pocket is fine. Let's hide the binder. And the sketch. Okay, so until this point, it's fine. We mirrored it to the other edge. Okay, we got the binder. Why is the binder in the correct position? But this entire thing is not in the correct position. Okay, so I deleted the pad for this binder. Now if I pad it again, but that doesn't make sense. I just deleted something and added it again. Moving platform dot rail length. Okay, now it works. What? I mean, I didn't do anything. Yeah, things like these is what FreeCAD must fix. So the model was broken for no reason. It makes no sense. So I deleted the thing it was complaining about and then did it exactly the same way. The exact same way, and it worked. Anyways. Yes, so now that we have the motor holder, not the motor holder. Now that we have this hole done, we can add a new body, and we should probably rename this to rotating screw params. This will not break anything, right? No, cool. And maybe to follow the naming convention, add spaces. Okay, cool. So now we have a body, but this body is right here at the start. We want to move it here. So in the X position, we are gonna go by general dot thickness. Now we're at this line right here. Add general dot tolerance, because There's a small tolerance in between the two. Then what was the base plate? It was base plate dot, or no, it was in general. Base plate length. So now we're at this line, and then I want to go to the middle of this. So we need to add half a thickness, or we can just multiply this by 1.5. Let's see. We should be, no. Why? So 1 thickness and a half. Tolerance and the base plate length. Interesting. Oh, we need to remove. Okay. We need to remove a half, so my bad. Multiply by 0.5. Yeah, that's because we did this exactly on this line and not outwards. So we have to go back by half a thickness. So now this new body that I just created is exactly at the center of this lure, but in the only on the X direction. We also want to move it up. So in the Z direction of the placement, we want to go up by general dot height minus motor holder params dot offset from top minus motor holder params dot diameter divided by 2, the same value we used to create this and this for the center. Now it's exactly in the center. So that's from the top view. You can see it in the center, and also from the side view and from the back view. Okay. Now we need to create some stuff. Let's see. What did we define? So we need 2 bearings. We have a diameter for we have a bearing outer diameter and a diameter. So it's gonna be, let's do the bearings first, and then it's gonna become more obvious. So we need to put a bearing here and a bearing here. So how are we gonna do this? We can create. Do we want to create an additive cylinder? No, let's just do a sketch. So I'm gonna show the origin again. And if I create a datum plane, then select the YZ plane. Now we can see it from this side. I can move it in the normal direction, which is the Z. Yeah, so I can move it this way or the other way around. We're gonna start with the positive direction. And how much do we want to move it? Basically by half a thickness. So general dot thickness divided by 2. And now we're here. Let's hide the origin. Okay. So if I select the datum plane, even though it's hidden, and then click create sketch, we're actually attaching it to this sketch. So we need 2 circles here, the inner and the outer diameter. Let's constrain the outer diameter first. So this is gonna be what was it, the rotating screw param dot bearing outer diameter. And the rotating screw params dot bearing inner diameter. Cool. Close it. Oh wait, we need to call this bearing. Yeah, that's fine. Interesting. I didn't think this through. Because the thing with FreeCAD is in the same body, this blue icon, you cannot have two solids. So now I'm trying to create two bearings and then the part in the middle. But we can't do that actually. My bad. We cannot do that. So what we're gonna do is... Oops, sorry. Need to delete the datum plane. Now the sketch is gonna complain. Can we set it to body? Where is body? It's the YZ plane, I think. Yeah, it's the YZ plane 3. Yes, this one. And now we can move the body in the X direction by thickness. So basically I moved the body here. And now we can pad this inwards by rotating screw params dot bearing width. Yeah, this is gonna be an issue. We'll fix it in a bit. We will fix it in a bit. Okay. For the other part, we can simply clone it and move it. Let's see. So we can clone the body, and now we want to move it in this direction, which is the X direction. But how much do we want to move it? We want to move it, I think, by the thickness, right? Minus the bearing width. No. Wait. Oh, it's negative. So we can do minus and then put all of these inside brackets. Okay, but now the bearings overlap because the bearing width is 6, so 2 of these is 12, but this is 10, so we need to add a condition here. Now we can change the general condition, or we can make a condition just for we can make a thickness just for this, but I'm gonna change it in general. So the width, no, the thickness. So what is the minimum thickness? It's going to be a rotating screw. We need to get that from rotating screw params the bearing width multiplied by 2. This will be exactly 2 bearings, and then let's give a padding between the bearings of 1. So now it's 13. This is our minimum thickness. But we have a problem. What happened here? Let's see, body 4. This is interesting. Wait, I might have done the calculations wrong. So it has a width of 6, for example, and currently it's starting from here up to 6. And I want to move it this way by the difference between the thickness and the width. So I moved it this way by thickness minus bearing width. Yeah, this should work. Interesting. Position. Oh wait, this is not parametric? Cloning should be parametric. You know what? I don't trust FreeCAD. I'm gonna create my own body. Move it in the X direction by general dot thickness plus tolerance plus plus general dot base plate length. Wait, this is gonna be here. I wanna get it back here, so basically I don't have to add the thickness. Cool. And in the Z, we need to go by general dot height minus motor holder params dot offset minus motor holder params dot diameter divided by 2. Okay, and now we can take this sketch, create a subshape binder, and now we can just move this by, is it minus? I think minus general dot thickness. Let's see. Yes. Now we can pad this inwards by the rotating screw dot bearing width. So these are the ball bearings. Let's make them smaller. Let's do 4 mil. 6 mil is okay. What now? Okay, this subshape binder is causing lots of issues. I might stop using subshape binders. Did it work for the bearing? It worked for the bearing for some reason, but down here it doesn't work. So, yeah. We have to remove it. Is the pocket still there? Yeah. Now we can pad this again. Need to make this active or it will not work. Reverse direction. But I have to fix this at some point. I can't just keep deleting it and adding it again. This is the second time I do that. Okay, anyways, let's ignore this for now. So, we have 2 ball bearings. We should probably give the bodies some color. Let's rename this to bearing 1 and this one to bearing 2, and let's click the motor holder. Random question: do you work or study? How did you get into CAD 3D design? Thank you for the question, and it's fine for e- even if it's random questions. Actually, sometimes it helps me concentrate if I'm talking. So I work. I'm a software engineer. And how did I get into CAD? It's because of lures. So I was making fishing lures from wood, but I hated the process of making wooden lures at home. Yeah, I think red is fine. Not just because it's too much work, too much like handwork and stuff, but because it causes a mess and you need lots of tools and stuff. So I was like, okay, initially I thought, what if we could CNC machine a lure from wood? Because I saw someone do it on Instagram. I'm like, I'm curious. I want to do that. So I have heard of Fusion before by someone called Malossi Lures. Not someone, they are two brothers, but I don't know if you follow them on Instagram. They make amazing saltwater lures. So I said, you know what, I'm gonna learn Fusion. I did that. I made a lure. I actually tried to CNC it. I went to someone. I gave him the files and told him like, can you do the half on one side and then flip the piece of wood and do the other half on the other side? And it took a couple of tries, but he did that, and it costed me like so much money. I'm like, no, CNC machining is not the way unless I get my own CNC, and then it's gonna be another type of mess. So that's how ended up buying a 3D printer. And I enjoyed the process of creating 3D models more than making the actual lures. That's how I ended up here. And then I was using Fusion 360, but I wanted something where I can own the files because I was planning on on selling the files at first. And with Fusion, you need a license for that. And then I didn't want to use Fusion because, like, I mean, I could easily afford it, but I don't know. I think it wasn't something necessary for me to invest in such a program. So that's how I ended up learning FreeCAD. But FreeCAD for lures is it's very tricky. I tried to do it. It's not that great for curves and stuff. There are workbenches, like the curves and curved shapes, I think. Yeah, these two workbenches, you could probably make a lure from it, or just by lofting a couple of shapes. But I decided to learn Blender, and when I started using Blender for lures, I just stopped using CAD. Blender is amazing. That's great, exactly as me. I work with software development and started fishing and wanted to do my own lures as well. Started with designing soft lures, masters. I do silicone molds around. I used Fusion in the beginning as well, but found it's easier to learn Blender. Yeah, I mean, easier to learn Blender. I think it's not easier. Unless you're talking about like super complex shapes, then yes, it's easier to make complex shapes in Blender than in Fusion. But I think Fusion is very user friendly. Like anyone could use it. Blender, on the other hand, there's a learning curve to it. I mean, we as software devs, like tech savvy people, we could probably pick it up fast, but other people might struggle a bit. Yes, this is exactly how I use FreeCAD for mechanical stuff, specifically. And so far, regardless of these random bugs that happen, I should probably save, by the way, because I had a couple of crashes on live streams. Only on live streams. I have no idea why FreeCAD never crashed on me. except on live streams. Probably because of OBS and all the stuff that's open on my PC when I'm streaming, but yeah. So yeah, as I said, when we're working in the part design, which the workbench I prefer to work on, it's different than when working with part, because here every single solid object has to be its own body. So now I want to create the screw thing, so I need to create a new body and probably also move it to place. So again, I need to go to data, position, blah blah blah, lots of repetition. General dot thickness divided by 2, if I remember, then tolerance. Lots of math when doing this. General dot base. Now this project doesn't have lots of math in it. I had projects where I had to get a piece of pen and paper and start writing math equations to figure out a formula to get something to work. It was cool though. I liked it. General dot height minus what was it? Keep forgetting this. Moving platform params dot offset top. No, not the moving platform. It was the motor holder params dot offset from top minus the motor holder params dot diameter. I could have probably created added this to the spreadsheet instead of typing it 100 times, but what the hell. Not easy, but I somehow managed to get what I wanted done after some good videos. Yeah, you should probably watch the live streams I do on Friday. I figured out a way to do the base shape of the lure fairly quickly before I go to sculpting and do like the minor details. But the base shape, if you worked with Fusion, you know how in Fusion you add a form. If you search like Fusion fishing lure tutorial on YouTube, they all do the same. They start with a form that is a pipe, and then they start modifying it like up and down, and then and the X and Y with symmetry. I found a way to do that in Blender, and it's super easy. It's a lot easier than like moving vertices one at a time or edges. But that's for like the base shape. Then you can do more detailed stuff later. Okay, so we're back here in the middle. So what I'm gonna do now is I'm gonna model one part and then we can mirror it. But the thing with mirror here in FreeCAD, it's a bit different than Fusion. Let's do a quick experiment just to see, because I haven't tried it, but I remember I did try it once. It didn't work. Maybe it could be something else. So if we do this, then we draw a sketch here, for example. Wait, what? Yeah, sketch here. Why isn't it? Okay, now it's working. And then do that. This is just a test. Let's see. So if we do this, can we mirror both? Mirror. So we need to mirror on the YZ base. YZ. No. Yeah, that's the problem. Oh, because it's mirroring one feature, which is the pad 9. So if we add a pad 8, oh, okay, we can do that. Okay, it's possible. Cool. So we can Wait, delete this, delete that, delete this, delete that, delete this. So yeah, we can model everything on one side and then mirror it. So let's start with adding dimensions. So the first thing we need is this section right here. And this is going to be the inner diameter of the bearing. So rotating screw dot bearing inner diameter. But we need some tolerance here. So I remember we had a tolerance, or you know what? I'm gonna use the general tolerance multiplied by 2. I usually do start with cubes that I extrude in different directions to create the basic outline of the lure. Not learned sculpting yet. I subdivide, adjust faces, and use subdivision. Get quite good result, but we'll try to learn some sculpting to improve the details. Yeah, no, I'm not talking about sculpting. So yeah, sculpting will definitely improve the details, but what I'm talking about is I used to do exactly what you're doing, which is start from a cube, add a couple of lines, right? Subdivide it and then move the vertices. It's the exact same process, but after you add the subdivision surface modifier, you know what? It's not a Blender tutorial, but what the hell? So if I add a cube, let's apply the scale, always apply the scale. Let's say something like that. And then you would do something like this, right? And then maybe something like this. Okay, and subdivide, Control 4. Okay, cool. So now you can go ahead and move stuff around to get the shape, and you can also do symmetry here, right? Yeah, but here's the trick. If you click this on the subdivision, it's called on cage. Look what happens. And now I can go to face select, for example, select this and move it down. You see what I mean? Something like that. So what you could do is, for example, select these, move them down, something like that. Move it down a bit. And then you go to edge select, select this edge, move it down, select this edge right here, move it down, something like that. You can do the same on this side. Move it on the X. But I prefer to use edges here in this case. See how easy that was? Anyways, back to mechanical parts. Something is wrong here because this is 0.2, this is 0.1, but it's not actually double. Tolerance times 2. Interesting. Let's see what we did wrong. Oh, it is. It is times 2. What? Looks... Is this the double of this? I don't know. Just to be sure. Bearing inner diameter. Oh, did I add? Did I add anything here? No. Anyway, never mind. I could be wrong. Maybe it's maybe it is. So we need to pad it. Which way do we go first? Should we go outwards or inwards? Let's go inwards. So pad it inwards. We need to go until this face right here, and then some tolerance ahead of it. So that's gonna be thickness, no, general dot thickness divided by 2 plus the tolerance. Okay. And now, what was the weird bug? It's gone. And now we need to create a datum plane, attach it to this plane right here, move it in the Z direction, negative Z direction, by the same amount that we did. So general dot thickness divided by 2 minus general dot tolerance. Okay, hide the origin, hide the plane, create a sketch. And this is gonna be our actual, what was it called? The rotating thing, the diameter. This is the actual diameter of the screw. And we don't have, at the moment, we don't have a screw length. Let's do 10 or 15. It's our input, and the output will be, yeah, basically the way how I do it with complex forms. That's very useful. We'll try to join the live stream. Missed the last one. That looks interesting. Yeah, the last one, it was interesting, but I messed up the scales a bit, even though I did them manually one by one, which should like create better scales, but for some reason they don't look better. The best scales I did was this lure right here. I think the reason they were this good was because the scales are big. Look at this lure, for example. It's not very, I don't think you're gonna see them because they're small, but they're not as rounded and as beautiful as these scales. But anyways, I'm working on a way to make the scale thing easier. I'm working on textures that I can like import and just brush it on a lure, and then it's done. Probably will sell them later. We'll see, or give them to members of the channel. I haven't decided on that yet. So max screw length input. So the minimum value for the screw length, let's set it to 3. Probably we need more. No, we need more. I will set it to a minimum value of 5. Because we need to do some threads. We'll add them later. For now, we need to pad this. Reverse direction. Rotating dot screw length. Okay, cool. The scales on that one looks great. I have been trying scales but not been satisfied and skipped them. Yeah, there are many ways to do scales in Blender, but it's, how do you say this? So you either have to get like really good scales, your only way is sculpting at the moment. But what you can do is similar to this, but it doesn't look that good. Um, I did this in Inkscape. Basically, it's an SVG, or I exported as a PNG, but it could be an SVG. It's a semicircle that repeats in a grid, like on the X and Y, and it's seamless. And then this becomes a texture when I imported to Blender as a texture, and then use it on the brush, and then I can brush them on simply, like just swipe it on, and it will look like this. So I'm trying to create a texture with these scales, basically. Then we can swipe it on any lure. That would be amazing. Okay, now we need to turn this into a screw. To turn it into a screw, we need a pitch. And what else do we need? So basically, I mean, we can download the threads thing, but I like to model my own threads because I can make them printable. So we can do that. If we can draw a sketch here. Yeah, we can draw a sketch here that starts, let's see, like that. Basically something like this. But it has to be printable. It must have like an angle that's not very steep. But the thing is, no. Wait. Delete. I think the best option is to do something like this. Something like that. And I'm gonna add a construction line because I want to put this point right here, and I want these to be symmetric. So we're gonna make this construction geometry. We don't want it included. I'm gonna take this point, and this line, make them symmetric. Basically, it's midpoint. And then this point, this line, and make it symmetric. So we can put this point here, and we can define an angle and height. So for the angle, uh, 30, no, 55, 45, I think. 45, this is gonna be the maximum angle I can go. Then 30 would be too extreme, I think. This should be fine. But you can't use the brushes on meshes with unapplied modifiers, right? And I will now stop talking about Blender. No, it's fine. It's fine. Don't stop talking. Don't. It will become boring. Yeah. Okay. So with sculpting, you don't want modifiers. No. It's a destructive workflow. But what you can do, what I usually do is start with the base mesh as I showed you earlier. Then I will apply the subdivision, but I would not do an extreme subdivision. So I will do it until like 15,000, 20,000 faces, something like that. And then, so this part is going to be destructive. So once you do that, you cannot modify the base shape of the lure, not the details. And then I will start sculpting using a multi-resolution modifier. So the multi-res modifier is not destructive because it will, I mean, until you apply it. But before you apply it, it's not destructive. It will save the 0% detail or the level 0 detail, the level 1, level 2, level 3, and then you can go back to level 0, basically no sculpting at all. Go up to level 1. It's like, I don't know if you tried game development before. It's called level of details, LOD. It's like a low resolution mesh and then a higher resolution mesh. But yeah, at some point I would save an incremental version of the file, apply the modifier, which will give me a mesh, like the finished mesh, and then I will start adding eye sockets and stuff like these. All the Boolean modifiers, but I do not apply the Boolean modifiers. I do not apply them, never, unless I want to do it temporarily without saving, just to test something and then revert back. But yeah, Boolean modifiers, I do not apply them because I want to move. Let's say I tested the lure and it's not sitting straight, so I want to move the weight position, or I want to move one of the hook hangers, but everything else is applied. The base shape and the sculpting and the scales and everything, all of these are applied. Okay, where are we? This thing. Yeah, we want to constrain this point, basically. Let's see, we need the height of this is going to be diameter divided by 2, and then this distance is going to be the bearing width. Oh no, not the bearing width. Sorry. Huh. It's going to be general the thickness divided by 2. So now we're here, and now we need to add a tolerance. So general tolerance, and the rotating screw dot screw length. Yeah, we're exactly where we want to be. Cool. Okay, that might be an issue later, but anyways. So the width is important, and we need to define that. So we need the screw pitch, and we need the screw or the thread width, and this could be thread pitch. Let's see how it will look like. How much is this? It's 1.5. If we did it as 1, what's gonna happen? That's like 0.5 mil, that's nothing. 0.5 mil. Is it? Yeah. But you can use the brushes on measurement and apply. I see the destructive part is what have stopped me many times, because I won't try the lure before doing the final details. I use render levels on the subdivision modifier when working and make it higher before exporting. But okay, I see what you mean. So you think that you might want to modify the base shape when testing, not just like the position of the weights and the position of of the hook hangers. You can technically still do that, but with a high detailed mesh, it might be a bit slow on the computer, but possible. Because in Blender, let's say you have, because this is basically the same analogy I did before with FreeCAD being like an SVG. Blender is like modifying an image. It's like Photoshop. You can do whatever you want with it, even if it's already done. So you can technically, let me add like 5 subdivisions here. Scale it on the Y, for example. Oh, come on, what happened? Yeah. Let's say you applied this, right? Oh, oops, no. Not delete it. Apply it. You can still go to edit mode. Go to X, for example, here, select these. And let's say you want to change the shape. You want to make it thinner here. I mean, if you scale now, it's not gonna look good. But if you turn on proportional editing, then scale. Whoops, you can do something like this. Yeah, it's still possible, and you can also do like scale only on the x-axis. And now, oops, no. And now you have a scaled down. Like we changed the shape, even though it's destructive. So yeah, you technically can. It's not gonna be as convenient, but yeah, but it's still possible, and you can do it in sculpting. It's exactly the same thing. Go to the grab brush. Grab, make it bigger, and now you can do this, but you want to turn on symmetry. So you can do that, for example, do this, move it out. You can do whatever you want. Yeah. Yeah, proportional editing thing is okay. So when using Blender, you're gonna figure out new things every every once in a while and say, "Oh my god, I wish I knew this from the beginning." Like, do you know about, for example, the shrink wrap and what you can do with it? You can do with it so many cool stuff. I can't find it, but I think it's here in deform. Shrink wrap modifier, yeah. Shrink wrap is amazing. Snapping is amazing. I sometimes use it for the eyes, not always, but if we move this here, rotate it on the Y by 90, for example, if I turn on snapping and then turn auto rotate and face nearest, I can now move it along the body, put it wherever I want. It's not rotating correctly, I think. Face project. Yeah, face project, sorry, not face nearest. It will even rotate it. Now, how deep you want it to go? You go to tab and set this to local. For example, show the gizmo. And now move this up. Something like this. Whoops, okay. Snapping is still on. Local. Yeah. And then turn snapping on back again. Look at that. Blender is so fucking cool. Anyways, we have a small problem. So this is 1 mil. I might do it 2 mils. Let me see. Yeah, we can probably do 2 mil. Why not? Or 1.5. No, this is gonna be how much? Measure this 0.7. So we can make it as 0.6, which is 0.6 divided by 1.5. We can do it at whatever this value is, multiplied by 0.4. What did I call it? Thread width. Yeah. So this can be 1.5. I don't know what the pitch will be, so I'm gonna leave it empty for now. This is the input. Let's give it a minimum value of 0.8. Is this song repeating? Yes, it is. Which song are you? I have done that manually so many times, adjusting the eyes after adjusting the shade. Yeah, I know, me too. That's how you learn. You keep doing it manually until you figure out a better way. Sometimes I'm like scrolling through YouTube, just watching random stuff, like watching shorts and stuff, and then someone does a thing, I'm like, my head explodes. Okay, so we called this one the rotating screw parameters dot thread width, and then we'll do this one at the rotating screw parameters dot thread width multiplied by 0.4. Cool. So now we want to go here, create an additive helix, and it's gonna break now. So what is the axis? It should be the x-axis. Cool. So cool. But what the fuck is this? So I want it to be like this, but I don't want it to go outside. So I might keep it like that, but then cut the excess, because I want it to start here. I want it to start here. Yeah, because otherwise it will not fit. If it started from here, how it will fit into the other one? This part will not get through, the higher part. So yeah, this is how it's gonna be. We'll cut the rest later. Now we wanna thread it all the way up here. So pitch, height, angle. Height is going to be the rotating screw parameters dot, what was the height? No. Screw length. Okay. Oh, now we have to cut this. It's fine, it's fine. We can still do that. The pitch, I don't know. This is too much, I think. Wait, what's going on? The axial distance. What is going on? How much was it? Huh. Interesting. 3. Okay. Yeah, that looks fine. But why did it break at 2? This is 1.5 from here to here. Is that like a bug or no? Oh no. No, it should work. $2.5, does it work? How are we gonna set the minimum value for this now? Based on what? The problem is I have no idea. The angle of cone that forms a hull around the helix. Non-zero value turns the helix into a conic. Oh wait, yeah. I think, okay, so basically at the moment we're doing a helix on a cylinder, but you can do it like on a cone, something like this. That's the cone angle. But the pitch, it should be the axial distance between two turns, right? It should be the distance between them. What the wait? What is the distance between this? No, it's not gonna. And come on, select that edge. This, for example, it's 1.5. And then we have one. Okay, so it's taking it from the center. So the distance is from the center of these two lines to the center of these two lines is 3. We have this entire thing is 1.5. So we have 0.75 and 0.75. That's okay. It could be the minimum distance could be multiplied by 2. Thread width multiplied by 2 is the minimum distance for pitch. So if we set this to 1, for example, let's call this the input. We should probably also need a maximum value. Let's see. This is going to be thread pitch input. And the minimum value is the thread width multiplied by 2. That would be 3. 3 is the minimum. What is the maximum? So we need minimum, and the maximum should be, let's say the maximum is half the screw length. Let's try that. Screw length divided by 2. And this is gonna be the pitch. So screw length is 15. Half of that is 7.5. Can we do a 7.5 pitch? No. 6. What? What's the error here? It's doing it inwards or what? Left-handed? No, this doesn't make sense. Nothing is working except 3. Should we hard code it to like double? Just set it here to whatever we enter in the thread width multiplied by 2, but that doesn't make sense. So if thread width is 2, man, FreeCAD. Oh, come on, FreeCAD. Yeah. Yeah, it is. Probably because I used 4 edges here to make this. I should have made something simpler, but it shouldn't do that. I've made multiple screws before. Huh? Looks like we found the magic number. I don't want to waste too much time on this. I'll debug it later. It's already like 11 p.m. Now what we want to do is let's start by cleaning up the back so we can actually hide the moving platform for now, hide the bearing and this bearing. So to clean this up should be easy. Wait, this is, yeah. We can start from this plane. Create a circle here so we don't clear this part. And this is, what was this? This was the inner, wait. Okay. This is fine. And then another circle. I should probably memorize the the shortcuts. But with the amount of Blender shortcuts that I know, I don't want to mess my head up. So rotating screw params dot diameter, just multiply by 2. As long as it's more than the diameter, we're fine. So now we can pocket this in the opposite direction. No? Huh. Through all. Nothing is working today. Result has multiple solids. How? Cancel. Oh, wait. Wait. What? No. Show direction. We're along the minus X direction. No. Oh, wait. Minus X is a sketch normal. We need to reverse it, but it's not working. Through all. Why would it create 2 solids? I don't get it. Sometimes I just don't get FreeCAD. You know what? Let me try something else. No, not circle. Arc. Okay, but minus. What? Oh no, no. Yeah, I was thinking right. So minus the thread width divided by 2. Minus rotating screw param dot thread width. It should thread. Yeah, it should work. It's not gonna be. But let me see now. What's gonna happen if I go back here and change this to 2? Does it like circles? No. It refuses any other parameter other than 1.5. What the hell? Okay, there. Fit all. Now we need to mirror this. Okay, you know what? I'm thinking of one more thing. So right here, between these two bearings, we can actually add something to keep the bearings in place, but then we would have to insert the bearings while it's printing, like embed the bearings inside the print, but it would be a lot more stable. Then I would probably need to rework that tolerance, but it's something simple. It's just a cylinder that's a cylinder with a diameter between these two to hold this bearing in place, this one and this one. Let's hide this one. The origin is right here. Where is the origin? The origin is here. Wait, which origin am I seeing? No, the origin is here. Okay, yeah. So we need to create a sketch here, and we need a circle that is constrained in diameter. So I want to get the rotating screw params dot inner bearing diameter, and I want to add to it the rotating screw params dot outer bearing diameter minus rotating screw param dot inner bearing diameter, and then take these two together, divide them by 2. Something is wrong. What did I do here? It's exactly in the center. Close it, and then we can pad it by how much? Let's set it to 2 just so we can see what's going on. Reverse. We need to pad it by rotating screw screw parameter, no. General dot thickness minus rotating screw params dot bearing width. We should be, no, interesting. Yeah, thickness divided by 2. So we should be exactly here. And now I can remove general dot tolerance. Yeah, you know what? I'm not gonna remove tolerance because we already have a tolerance here. So we'll use that. And this is gonna be on the Z axis. It doesn't require that much tolerance. Okay. Now we need to take this, everything we did, and mirror it. So let's select this, this, and mirror. We need to mirror on which plane? Okay, what happened? Wait. We need to mirror on the YZ plane. Oh man. No. Why did it do that? What the hell is this? Thread pitch. Thread pitch is what? It's 3. Let's set it to 2. And then change this to 1. Okay, so at least this now works with 1. But why? Why is FreeCAD doing this? That is super weird. I am not going to redo this on the other side. No, black doesn't look good. I'm gonna keep looking at maybe looking on it, maybe it fixes itself. Let's try to restart. Nope. Is it refined thing? No. Data refined through when we did the helix. extrude symmetric to sketch face. No, it's not this. So we're doing it on the x-axis, pitch, height, angle. Height, turns, angle. What if we use this height, turns, angle? So we have the height, and let's say we want 6 turns. Is it doing anything? 6. Interesting. So this works, but oh, maybe it's not. It's trying to calculate the pitch, but it's unable to do that or something. I don't know. So let's do thread turns. Thread turns input is gonna be 6, for example, and the minimum is gonna be we need the minimum and maximum. So the minimum is gonna be 1 turn, or yeah, 1 turn, and the maximum, how are we gonna calculate the maximum now? So we fixed the issue with the pitch. We're no longer using pitch, we're using number of turns, and now it's working beautifully. But okay, so how many turns can we have? Let's see. First, screw length. No, we can't do that anymore. So the number of turns will definitely depend on the width, right? We have the width. The width here, let's say it's 1.5 mil, or what is it? Is it 1.5? It's 1 mil. Let's say the width is 1 mil. So the maximum is gonna be the height divided by the width, like the length divided by the width. This is gonna fill it completely, right? Let's see. Screw length divided by thread width. By 2, I don't know. We can do some math. Wait, let's do 20 just to see some errors. No? What? Oh, wait, sorry, my bad. It's rotating the... I forgot to change the name. It's no longer thread pitch, it's called thread turns. So here it's the rotating screw dot thread, then thread turns. And I have to click OK for it to update for some reason. Result is not a solid. Okay, no. So we cannot do the full thing. So the distance between one thread and the other one. Okay, let's do this visually, right? So we need to do some math. So the total length right here between this and this, the total screw length, what does it equal? It equals the number of turns multiplied by the width plus number of turns minus 1 multiplied by the padding between each two, right? So if we want at least 1 mil of padding between the two, we need to write this. We need some notes. Text editor. So the total length is T. The thread width is W. The thread turns is N, and then the thread padding is P. So T is gonna be equal to N multiplied by multiplied by W plus M minus 1 multiplied, I'm pressing random stuff, by P. So P okay, wait, we want the maximum value for, I lost what we were doing. We want the maximum value for number of turns. We want the maximum value of number of turns that we can get if we want P to be 1. We want P, okay. So we want P to be between 1 and something. You know what? I should just listen to you. Screw length. What did I do here? Screw length divided by thread width. This is the turns divided by 2. Maximum is 7.5. What? Is it because it has a 0.5? Is this what's causing all the issues? Can we round this? Is this how we round, by the way? 7.5? No, that's not how we round. Spreadsheet round. Is it round? FreeCAD spreadsheet round. Round up. Oh, it's round. Okay, so what was breaking the thing was the decimals. It should be an integer. Absolute? No, absolute will make a negative number positive. We want to turn it into an integer. We want to round it. So yeah. So now if I remove this, what's gonna happen? I think it's gonna break. Yeah, it's gonna break. Let's just leave it at that. This is the maximum. I think it's fine. But this works also. I don't remember how I did it exactly, but if I want to restrict the distance, like the padding, I can just do like padding. I want it to be like between 1 and something, let's say 10. And then if you put this entire equation here, when you have, of course, when you do like p equals something, then you put that entire thing here, then you can figure what is the minimum and maximum values of n, which is cool. Cool. I mean, this spreadsheet thing is super powerful. Yeah, the decimal thing is very interesting. Apparently, you cannot have half a round. You can only have full rounds. Like, these should line up. I don't know why, though. Probably a bug. We should report it to FreeCAD. Okay. So now, let me close this again. So now this can be printed. When it's printing, we can pause at this layer right here before it starts. Put the bearing in place, resume it. Then before it starts this layer, put the other bearing, resume it, and then we'll have two embedded bearings. Now, of course, these bearing numbers are generic. I don't know if there's even a bearing with these numbers. I need to check, but now we can update them whenever we want. What else? We did only one thing from the 10 things that I wanted to do today. But it was a fun stream. Oh, Odd Lures, you followed me on Instagram. Thank you. And by the way, we have a Discord server. If you're interested. And I also have a Twitch account. I should probably have the Twitch account link in YouTube. I don't have it at the moment. But on Twitch, it's different. I'm making a video game, and sometimes I stream some gaming stuff. Since we're done and I have nothing else to do at the moment, let's see the video game. No, is this it? Oh yeah, it is. Okay, so here's the idea. It's not actually a video game, but you see this green grass? So this green grass is actually a bunch of, it's similar to Minecraft. It's a bunch of cubes that are stacked, that are like placed next to each other. And what I did is I was trying to optimize a way to basically randomly generate stuff, like an infinite world, basically, based on some noise textures and things. But the thing is, you can't just simply generate an entire world. Your computer will crash. So when I move, it will start generating new stuff. This is what I was experimenting with. This is all math. And I fucking love it. And it has physics also. There's gravity and can keep just moving around. At the moment, they're all green. But in the future, they will be like trees here and stuff. Probably a fishing game. Most probably. What else do we have? That's it. If you have any questions. Oh, we have 2 new people on Discord today. Cool. If you have any projects idea, by the way, we have a projects idea channel. I'm thinking of adding more channels, like one maybe for game development if someone is interested, just a random thing. Maybe a gaming channel if someone like decided to play a game someday and we're all bored. we can jump and play a game. Now, regarding this, we're gonna continue it next Monday. It's about 12 p.m. We still have lots of stuff to do, but yeah, I mean, adding a stepper motor here would be cool with some enclosure, maybe a fan to cool down the motor, an Arduino board down here with a switch and a couple of, oh my god, that would be amazing. I'll think about it. Maybe we'll do it. I think I'll go for it. This has to be bigger, of course, to house the stepper motor. It should be just a small pancake motor, I think. Will be plenty enough. Yes, yeah, you can use seeds. Game development is interesting. It's very interesting, and I've only recently started getting into it. I did at one point in time, like way back 6 or 7 years ago, try game development, but I wasn't as good in programming as I am at the moment. So yeah, time to sleep so I can get up for work tomorrow. Well, I wish I can say the same thing, but I was laid off, so but I still wake up early. So yeah, we do have to sleep. Will be fun to watch either way. Thank you so much, Oddlures, for the engagement today. I love it when someone is sending messages. It makes the stream a lot more fun. And oddly enough, it helps me concentrate. I don't know why. It's very weird. I'm glad we fixed this thing. There's one bug that I haven't fixed yet, which is, I'm gonna save now so I don't break it, but if I change the width to like 200, okay, what? Now it's fixed. What? It used to break for some reason. This thing. FreeCAD is super weird. Super weird, but okay, now it broke or what? That's definitely not 150. Oh my god, and it's saved. Okay, now it froze. 150 with 100. Okay, no, it's working. Anyways, that's it. Thank you guys for watching, and have a good night or a good day if it's not night for you.